Hello everyone. So today we are going to implement this simple color picker widget that, as you can see here, we have this color selection area. Here we can select any color we need, and then we can change the saturation using this slider and the value using this slider, and we can change any color we need for the mannequin character. So yeah, this is what we are going to work on today. So first we are going to work on a material that we can get. So this is not a texture. These colors are taken generated in the material using texture coordinate and HSV to RGB conversion, and then we are going to see how to use that selected color and how to apply it to the mannequin. So first part we will be working on this material where we generate this color table, and in the next part we will work on the widget itself and these sliders and this 2D slider and everything. Alright, let's see how to do this. And this episode is sponsored by this generous patron. Thank you very much for your support. Okay, so this is our project. So in here under UI, let's create a new folder, color picker. Okay, so I'm going to implement this type of a color picker where we match the horizontal value texture coordinate of this texture into the range of colors. Right, so I'm not going to actually use some color picker texture here. I'm going to implement the color picker, this color selection area with the material, so that we can properly understand how does the linear to RGB conversion happens. How do we map some value between 0 and 1 into all the range of colors we have. Let's call it M color pick. Right, and I'm gonna use the material domain to user interface because I'm going to use this with user interface. So here as input, all we have is texture coordinate. So if I directly plug this, we will get a color like this. So what this means is we have this texture coordinate is a 2D texture, 2D vector. So we have x and y values. X is horizontally, this side is 0, this side is 1, and y is vertically, this here it's 0, here it's 1. So x is mapped to R and y is mapped to G. So that's why in this corner we have green, in this corner we have red. If I break this to float 2 components and plug only the red component, you will get you see here we have 0, here we have 1, and for all the RGB inputs we have given the R input. That means 1 at this end, 0 at this end. So that's why this is completely white here. So if I do something like this, make float 3 and connect only the X, which is R input, we get only red. All the other colors are 0. So if I connect again green to Y, that means the vertical. So here we get green. When we go down, we get green. If I break this, you can see everywhere is green when you go down. Okay, so if we have only 2 colors, let's say R and G, we can perfectly match a 2D plane into all the possible colors and get variations. But unfortunately we have 3 basic colors, R, G and B. But in UI, for UI component, we can't have a 3D representation. We can only have a 2D plane as the color picker, so we need to find a way to somehow derive all the possible colors with these two dimensions available. Right, so for that we have this HSV to RGB conversion function. So here we have the function roughly in this website of I'm not sure how to pronounce this. So yeah, in this blog we have the necessary function, so I'm going to use it and implement the color picker. Okay, so in HSV, input is going to be a vector 3 or float 3, so let's make float 3. This one is, let's add a reroute node. No need. Let's call it this one HSV. Okay, and if I break this, R is H, sorry, yeah, R is H, G is S, and Z is, and B is V. Okay, so for the conversion, let's map the red value, that means this on horizontal axis value as the H. Okay, and these two for now I'll set constant, not 0 for both. I'll set 1, S and V. Okay, and according to the function, let me go to the function again. We need two more variables here in order to calculate the final value. Right, let's start with this K. So make float 4, and this is K. Right, now the K is created with these values. X input is 1, Y input is 2 divided by 3, and Z input is 1 divided by 3, and W input is 3. So this one is, well, it's just a constant 1, and this one 2 divided by 3. So let's add a division. Here I'll set 2 divided by 3. Okay, and Z is 1 divided by 3. Another division, 1 divided by 3, and W, that means A, is 3. So I'm not really going to explain how this function is derived. Some smart people have figured that out, so let's just use it. Right, the other thing we need is P. P is float 3. Right, so in order to get P, first we need to get a vector created using X value of HSV and two XYZ values of K. Right, that's the first thing we need. So make float 3, and all of them should have let me put it here, x value of HSV. That means the R output of this HSV float 3. Then we need another vector 3 created with x, y, z values of k. So let's break this again to float 4. And make another for float 3 with x, y, and z values of k, like this. And then get the fraction of addition of these two vectors, frac. Actually, I'm not sure what frac operation means, but anyway, we have the node, so let's just use it. Then we need to multiply it by 6 according to the definition, according to the function. Then subtract another vector created with w value of k. So make float 3 created with w value, which is a of this float 3. This one subtract this one, and finally get the absolute value, and we call it p. So result of this node is p. Right, now we have both k and p, so we can define the final result, which is created by this function. First part is clamp p minus K.xxx into 0 and 1. Okay, so first part is p minus K.xxx. Right, here we have p minus K.xxx. Make float 3. X is this R value. Actually, we could do it like this, so we can reduce the complexity of the connections. Okay, so this part is p minus K.xxx, and we need to clamp it between 0 and 1. So by default we have 0 and 1 as main default and max default. Then we need to loop K.xx with the clamp result. So clamp result loop linear interpolate, A is this one and B is K.xxx, which is this one, and alpha value is from S, that means the in HSV inputs S, that means G. sorry, where is HSV? Okay, here, G, that's the alpha value. Finally, multiply it with V value of HSV. That means B component of here, B component. Right, get this, multiply the final result. Now this is the converted result. So we should be able to connect this to the final color. No, sorry, in this lerpin, first input is K.xx and the second input is clamp result. But here, yeah, I have connected K.xx to the B, so this should be interchanged. Okay, so now we have converted the linear value, the X value, to full range of colors. Right, now if I connect this G in G result of breakout vector 2, that means the Y component of texture coordinate, into either HSV S value or V value, this is what happens. Let's connect to S value. You can see this top part is white, and if I connect to Z or V value, top part becomes black. In this example, actually the bottom part is the black, so let's use some 1 minus input, 1 minus node here, and connect to Z. So you can see bottom part becomes black, darker. Right, now let's apply this and let's create user interface widget. Let's call it color WDG color picker. Okay, so I'm actually not going to make it more complicated, so let's just add a button, or maybe not a button, just a border. Yeah, let's set the anchor to top left, position to 0 0 0, and size X 300 by 300. Would this be enough? Let's say 500 by 500. Right, now here as the brush, we can set a material. Oh, we don't have to create one. Let me drag and drop this M color picker. See, now we have that colors available to us. Okay, so then we need another slider, 2 more sliders to change here saturation and brightness, and also just like in the default color setting, we have maybe need another preview, maybe not necessary a preview to show just the selected color. And I don't think, I'm not really going to implement these options, because this is going to be just a simple color picker for like setting up the armor color or skin color or something like that for a character. So yeah, then we need to look into how to actually select the color when we click on some area. So I will look into those things in the next episode. Right, so as always, project files will be available for the download through Patreon page. Link would be in the description below. And thanks for watching. See you in another episode. Goodbye.